Here's number 31 from 1.4. So we're talking about a free-falling object on Mars, and we are given the position function for a free-falling object. So I'm going to note that here. This is the position function. It is s equals 1.86 t squared, where s is labeled in meters and t is labeled in seconds. So we're told that an object falls from 200 feet. I'm going to note that over here, but it turns out that because our question asks for velocity at a certain time, the fall from 200 feet in this, actually it's meters, excuse me, isn't going to matter so much because we don't care much about its position when we talk about velocity here. So the question says, find the velocity of the rock at time t equals 1 second. We want the instantaneous velocity. So we're going to do that with our limit of the difference quotient function. So here we go. We've got a limit as h goes to 0 of, we're going to call this function s. So it's going to be s of 1 plus h minus s of 1 all over h. We should be getting really, really used to seeing that function set up now. So this is going to become the limit as h goes to 0 of. We plug in a 1 plus h to the function. We get 1.86 times 1 plus h quantity squared. Minus, we plug in a 1 to this function. We end up with just 1.86. This is all over h. So now the limit as h goes to 0, we get 1.86 times, expand that 1 plus h squared. So we got 1 plus 2h plus h squared minus our 1.86. And let's see, this is all over h still. And how about this? The 1.86 times 1 minus the 1.86 here, can we say those make 0? And so that's going to leave us then with a limit as h goes to 0. The two remaining terms in the numerator, we should still go ahead and multiply by the 1.86. So this will be, 1.86 times 2, what is that? 3.72h plus 1.86h squared all over h. How about we factor out that common h in the numerator? So a limit as h goes to 0 of h times 3.72 plus 1.86h. There's still an h there because it was squared before, over h. And let's see, I can cancel those h's. And the limit as h goes to 0, the 1.86 times h will become 0. And this is just left at 3.72. It's a rate because it's instantaneous velocity. We know that s was measured in meters, t was measured in seconds. So this is 3.72 meters per second. And there we have it. That's number 31.